Ultrasonic flaw detection is a non-destructive testing method that uses the physical properties of ultrasonic wave propagation, reflection and attenuation in objects to find defects. In this class, we will learn about the operation of ultrasonic testing of welded joints. Ultrasonic flaw detection is mainly used to detect internal defects of metallic materials and some non-metallic materials. Ultrasonic flaw detection has the outstanding advantages of low cost, convenient operation, large detection thickness, and harmless to people and the environment. Learning objectives: 1. Understand the principle of ultrasonic testing. 2. Master the operation technology of ultrasonic testing of medium and heavy plate butt welded joints. 3. Accurately record and fill in the testing results and reports. Following my video, take the butt welded joints of medium and heavy plates as an example to carry out the operation of ultrasonic testing of welded joints.
1. A rough scan. A rough scan is for finding defects. In manual ultrasonic testing, zigzag scanning is often used for initial scanning. When performing a zigzag scan, the oblique probe should be placed on the inspection surface perpendicular to the centerline of the weld. The range of forward and backward movement of the probe should ensure that all welded joint sections are scanned, while keeping the probe vertical to the welding seam and moving forward and backward. It should also rotate 10 degrees to 15 degrees left and right. It should be noted that the pitch of each advance shall not exceed 85% of the diameter of the probe element. During the scanning process, it is necessary to make a rough scan on both sides of the weld. Suspected defect signals are found, and standardization is performed at the relative weld position for accurate detection. During the rough scanning process, if a suspicious signal is found, the echo is covered with a gate, and the echo depth and horizontal distance displayed on the screen of the instrument are read. Use a ruler to measure whether the echo position is on the weld according to the value displayed by the horizontal distance. If not on the weld, do not mark. If on the weld, mark the echo location with a marker and slowly move the probe left and right. Initially determine the size of the defect and mark it. A rough scan of the test panel found 2 suspected defects. Mark them as above. 2. Precise scans. According to the position of the above rough scan mark, the defect is precisely scanned. Move the probe near the side of the marked position. Find the highest reflected echo. Read the echo height of the defect on the screen as SL plus 16.8 dB and record it. Then scan to the other side of the weld to find the highest reflected echo. Read the echo height value of the defect on the screen as SL plus 18.8 dB. Compare the echo height values on both sides of the measured echo amplitude. And locate and quantify the defect on the side with the higher value. Three. Defect location and quantification. Hold the probe still, and adjust the echo height to 80% of the screen. Record the inspection data at this time, and read the horizontal distance of the defect echo as 50 mm. Use a ruler to measure the position of the defect in the weld and the distance from the highest reflected echo to the edge of the test plate is S3. The S3 of the defect is 140 mm. The echo amplitude SL plus 18.8 dB, and the depth of the defect is 10.4 mm. Move the probe parallel to the left until the echo height falls to 40% of the screen. Use a ruler to measure the distance from the center of the probe to the edge of the test plate, denoted as S1 equals 135 mm. Move the probe parallel to the right so that the echo reaches the highest wave and then drops to 40% wave height. Use a ruler to measure the distance from the center of the probe to the edge of the test plate, denoted as S2 equals 160 mm. Record the inspection data in the inspection report. According to the above method, another suspected defect is accurately measured and recorded in the inspection report in turn.
Through the operation video just now, we should pay attention to 1. During the ultrasonic testing process, we should pay attention to the sound beam covering the entire welded joint. 2. In the detection of primary and secondary waves, the amplitude of the defect echo or its indicated length should be measured. The primary wave with the highest amplitude shall prevail. 3. When measuring the same defect with different K-value probes, the indicated length measured by the K-value probe with the highest amplitude shall prevail. That's all for this class. Thank you for watching.